Algebra 2, 2.6, Part 2, Family of Functions. First thing we're going to look at is the parent function. This is the original linear function y equals 1x plus 0. Y equals x. Okay, so I've got points listed out there for you. If I plug in -2 for x, I get -2 for y, and so on. If I plug in -3 for x, I get -3 for y. And so then if we wanted to plot those points and connect the dots, then it will look something like this. Okay, the second one, y equals x squared. This is a function you need to know this year. So you should be able to plot these points. 0 squared is 0. 1 squared is 1. 2 squared is 4. If there was more space, I'd do 3 squared is 9. And 4 squared is 16, and so on. This is the parent function of the quadratic. Again, we'll get into this. We'll use this a lot this year. This is kind of our go-to formula. Try that one again. There we go. Okay, so we're going to use these two functions with all of our different translations. So in yesterday's learning, you were seeing f of x written. That is the same thing as saying y equals. Okay, the reason we use f of x is because you might refer to your original line as f of x, but your new line might be called something different, maybe g of x or h of x. We want to be able to name our lines. Okay, all right, so let's look at the vertical translation. So if we take that first function there, and I have it lightly drawn in blue here, and I want to move it up, actually down in this case, we're going -2 down 2. What I'm going to do is take each of the points that was on that original graph, so you think of those points, and we're just going to shift each point down 2. So we find a point, go down 2. Another point, down 2. Here we go, down 2. And so on. Okay, so that would be a vertical translation of -2. We went down 2. All right, and then we can connect the dots there to show that it's a line. Okay, if we did that same thing with the parabola, again, these are those points that you need to know on the parabola: 0, 0, 1, 1, 2, 4. Same thing on the other side. And we wanted to shift this one down to -2. It's at the end of the equation. It's not inside the squared. It's at the end. We're going to take every point and move it down 1, 2. Down 1, 2. Down 1, 2. And 1, 2. Okay, if there was room, I would want you to write 3, and then, so to the right 3, we would go up 9. This is like my new 0, 0. So I would want to write that from there if there was space. 1, 2, 3. So it goes up to 7 from that point. So if I had space for 2 more, I would make it go to 9. Just add that point over here also. All right, so go ahead and connect your dots. Just try to connect them as nice as you can. It's a little tricky to do. Just do the best you can. Okay, so that was that original function shifted down 2. All right, horizontal translation. So this is where we're going to move it left or right. And since our function says -2 in parentheses, it's -2. The original equation has a minus in it. So it's just going to be 2 to the right. So if I took each coordinate on this initial graph, and this one I actually already have done for us, I'm just going to take each point and move it 1, 2 to the right. 1, 2, 1, 2, 1, 2, and so on. Okay, and that's how you get that graph. So 2 to the right. You may notice that 2 to the right for the linear was the same thing as down 2. It's because it's a straight line. Okay, it doesn't look the same for the parabola. So for the parabola, 2 to the right would be taking each of those points. We had 0, 0, 1, 1, 2, 4. So you're going to want to get your original graph on there and then shift each of those points 2 spots to the right. 1, 2. Here's my new point. Starting at -1, 1, 1, 2 to the right. So it ends up at 1, 1. 0, 0, 1, 2 to the right. We're at 1, 1, 2 to the right. 2, 4, 2 to the right. Okay, and then just connect the dots. All right, so that was vertical translation. You're going to add that number after the function. So if it was x squared, we're going to add or subtract the 2 afterwards. But when you want it left and right, you're going to add or subtract in the parentheses. All right, the last main translation we're going to look at is the reflection. Okay, reflection across the x-axis. All right, we've got our points on our original linear line here. We're going to just flip these over the x-axis. So all these points in the first quadrant are positive, positive. We're going to flip them upside down on the x-axis so that they're positive, negative coordinates. So this first point that was 1, 1, if I flip it over the x-axis, it becomes 1, negative 1. 2, 2 becomes 2, negative 2. 3, 3 becomes 3, negative 3. Okay, and then on the other side, we can do the same thing. Now these points are below the x-axis, so if I flip these, they actually end up going up. And if there was a point on the x-axis, it's just going to stay there. Whoops. Try that again. There we go. All right, so then connect your dots. And there's the reflection. Okay. Notice this negative is out in front of the parentheses. That signifies that you're taking the entire equation and making it negative. So for this last one here, that's the parabola, if I make that entire equation negative, all the points are just going to again reflect. So find your original points. We'll do the table for this one too. If you don't need the table, you don't need to use it. It's just there if you need it. So let's just try these points here. So it was negative, negative 2 squared. So if I square the negative 2, I get 4, but we still had that negative out front. So we're going to say negative 4. Okay, negative 1 squared, which is just 1, negative 1. Okay, 0, 0, 1. So we have negative 1 squared. So 1 squared is 1, add the negative. Negative 1, sorry. Negative 2 squared would be negative 4. Okay, that's one way to do it, or you can just think of the reflection. So negative out front, made the whole equation negative, is going to reflect it upside down. So this point up here was up 4, now it's going to be down 4. Up 1, straight down 1. 0, 0, okay, 1, and negative 2, 4. All right, so those are the main translations. We're going to practice them here. Describe the translation from graph 1 to graph 2. So graph 1, I'm just going to graph this out just so we can have a visual of it. Y equals x plus 1. So our starting point is plus 1, up 1 over 1. So we're taking that original y equals x and we're moving it up 1. So that plus 1, think up 1. Okay, and then my new graph is going down 3. So if I do my new graph down 3, we want to say, what was the transformation from graph 1 to graph 2? So how many did it go up or down? Okay, so we were originally going up from the original 0, 0, and the second graph went down from the 0, 0. So how do I get from the first graph to the second graph? Okay, if this one's starting at down 3, okay, what's going to happen? Well, if I think up 1 and down 3, overall it's going to go down 4. So if I connect those dots and double check. So how would you double check? Just pick any pair of points on the graph and count. So we went down 1, 2, 3, 4. Yep. All right, second one. Here we go. This is a good practice for us. Think of what y equals x squared looks like. It's that parabola. Remember 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. Okay, so we want to know what is going on from that graph to the graph number 2. So since we have the minus 3, we're just going to the right 3 units. So if I make this graph go to the right 3 units, 1, 2, 3, 1, 2, 3, 1, 2, 3. There we go. And then go ahead and connect your dots. Okay, so that was that graph. All right, let's look at another one here. Make a table of values for the given translation. Plot the points to check your answer. Okay, so I actually already have the original one graphed. The original one, remember your coordinate is x, y, and we talked about that f of x is the same thing as y. So original coordinates, negative 3, 1, negative 1, negative 2, 1, 0, and 4, 3. Those are original points. Okay, now the directions said, make a table of values for the given translation. Well, this translation was 3 units down, which becomes our function minus 3. So our function, our y value, so we're going down 3. So we want to make our y value go down 3. So 1 minus 3, that first value would be at negative 2. Negative 2 minus 3, negative 5. 0 minus 3, negative 3. 3 minus 3 is 0. Okay, so go ahead and graph that out. So if we graph all those new coordinates, so when you graph the new coordinates, you want to kind of imagine that middle column is not there. We want our original x, but our new y. All right, part D. Without graphing, how did the graph of y equals x minus 3 squared plus 1 translate? See if you can fill in the blanks. So we want to go 3 units which way and 1 unit which way. Up, down, left, right. So go ahead and pause your video. All right, so we went 3 units to the right and 1 unit up. Okay, last 2 here. Write the function rule for each function. We want to reflect over the x-axis. So remember to get over the x-axis. We're just going to make our entire equation negative. So we're going to go y equals negative x minus 4. Okay, you can simplify that. So distribute that. Think of that as like a negative 1. We're going to go y equals negative 1x plus 4. Okay, so go ahead and graph that. See what that looks like. Okay, there's our graph starting at 4, down 1, right 1, down 1, right 1. And what we wanted to notice is that these graphs were reflections of each other. So if we kind of draw a line on the x-axis, that red one, if I flipped it upside down, it should match up with that blue one. All right, last one, go ahead and make that entire equation negative. And then when you distribute that negative, you want to put it through to the x squared and through to the negative 3. Again, think of it as negative 1. Go ahead and pause and I'll pop the answer up there. All right, if I distribute that negative, it's going to be y equals negative x minus 2 squared plus 3. So we have kind of 3 things we need to do. 1, reflect over the x-axis when we graph this. Another one, we need to add 2 to the right, so 2 right, and up 3. All right, so if I reflected it, that's what it should look like. And notice they all